Hello everyone, and welcome back to a new episode of Advent of Code. The last episode spent almost an hour writing like 4 lines of code, but it was sort of like worth it, right? You guys learned more about Haskell than if I had just like written 4 lines of code, I hope. Hopefully, a few of you who were interested enough in Haskell to like follow along, but didn't already know about it, like hopefully you sort of feel like you understood what happened there. Maybe between the last episode and this one you went and read some stuff, wouldn't that be amazing? I don't know, that's up to you of course. That is to say, certainly it would be amazing, but you don't have to have done it. Feel free to just follow along however you like. So we're going to move on to day 2 and hopefully do it with a bit more alacrity here. Day 2, corruption checksum. As you walk through the door, a glowing humanoid shape yells in your direction. You there, your state appears to be idle. Come help us repair this corruption in the spreadsheet. If we take another millisecond, we'll have to display an hourglass cursor. He's very gruff. The spreadsheet consists of rows of apparently random numbers. To make sure the recovery process is on the right track, they need you to calculate the spreadsheet's checksum. For each row, determine the difference between the largest value and the smallest value. The checksum is the sum of all these differences. For example, given the following spreadsheet, here it is. Okay, fine. So we get for each row, the largest and smallest value. And then you add those together across all rows. So great. Seems like the kind of thing Haskell is great at. Let's look at our puzzle input. Any weird tricks in here? No. It's all tab separated. My goodness. Okay. Okay, fair enough. So, yeah. This should be fine. And they're not single-digit numbers. That's something to know. They're tab separated, but, great. Okay, so let's now close this window, head over to a terminal. And I did something on purpose here. I wanted to make sure that I trusted myself with Tmux, and so I detached myself from the Tmux session just so I could practice reconnecting to it. Remember, practicing with Tmux here. And it took me a few tries. I had to look up how to do it. Not thumb. What in the world? Tmux. Attach -s for session, and I named my session AOC. It's not SH. It's ST. I get it confused with screen, which was like the precursor to Tmux, in which I'm also not very good at, but which I do still have a few habits from. And like magic, here we are in the middle of the file we were just editing. Our REPL is still open. Our shell is still open. Incredible. So first thing I want to do is I forgot to git add the changes to make day 2. Boy, this is a very small window, isn't it? Let's scroll up here. But I mean, like, yes, of course, we want to add everything. Fine. So yes, git commit -m day 1 part 2. Why does it feel like my typing is like really delayed and slow? Internet problems? I don't know. So if we wanted to look at git log, for example, we did day 1 part 1, we did day 1 part 2, very lovely. By the way, there's my email address. Don't spam me, please. If anyone scrapes email, if any bots scrape email addresses from YouTube videos, boy, that's got to be a low-paying amount of drudge work. Especially like, I don't know. Anyway, whatever. So now we're sort of done with day 1, right? So we want to go back to ASC day 02, cat into input.text, that, okay. Now out of curiosity, 16 lines, okay. Just curious, don't think that really matters much. Now my REPL in this other window is still, other pane, I should say, is still in the day 1 directory, but I think this should be fine for now. Oh, I should have looked up how to get Intero mode going between videos. I'm doing these like, I just ended the last episode a little while ago, so I'm going to try to get through a few of them tonight so that I can catch up to real time. But I should still like figure out how to get Intero going, because it really does help for writing Haskell inside of Emacs. Then we wouldn't need a REPL so badly outside of Emacs. But okay, whatever. So fine, we don't need any of this stuff. What we do need is to destroy that file and go to day 2, source, here we go. So of course, we've got the same hello world file that was here when we created the first I just asked for a simple hello world project from Stack, and this is what it gave me. There's a few things that would be nice to have in an Advent of Code project, like, so maybe I'll replace all of these default main files with a slightly better template, but for now this is what we have. So let's see. So main equals interact of. Now, last time I wrote show.solve, basically, right? But I'm going to do something. I'm going to teach you guys a little bit about the $ operator, which is basically, you can use it sort of, and this is not the best way to think of it, so like, sorry, I'm not doing a great job. It is used to reduce the number of parentheses that are needed to sort of simplify expressions. But it doesn't have any magical properties. It's just an operator which has very loose precedence rules. So it allows this to be, it basically says take the left-hand side as a function and call it on everything on the right-hand side. And it has such loose precedence rules that all other operators on the right side are resolved before the $ more tightly than the $. And so this is the same as calling interact on the parenthesized expression show.solve. And so this is what I would typically do. I only put in the $, like the parentheses last time, just so I didn't have to explain yet another weird Haskell thing in the first episode. So this is a really common thing to do in Haskell, is to, like, on the left side of a $, you compose together a number of functions, and then you put a $, and on the right-hand side, you take a value. And we're kind of doing the opposite here, where we have a function on the left which wants a very simple function on the left, just interact, and it wants as input another function, and so we can sort of compose together a bunch of stuff on the right of it. So here we're going to want at least like lines. So lines takes a string and returns a list of strings, where the list is all the lines in the string. But we need more than that. We want, how do you take a list and split it on a particular element? There is something for that in Hoogle somewhere. I have a list of string. No. I have a single string, and I want a list of strings. I have lines. I have words, which is almost what I want. Maybe it is what I want, actually. How does words work? Words delineated by whitespace. Okay, that's good enough, actually. Specifically, we have a tab, but whitespace is fine also, and we happen to have that already, so I'll take it, I guess. Okay. Words. So first we call lines, then we call words, and then we're going to call map read. Okay, yeah, that sounds fine. We'll get a list of all the ints. So that's how the structure of our sort of IO code is going to go. We're going to split it into lines. Map. For each line, we want to call words on it, so we're going to map words over lines. Once we've done that, we want to, for each word in the line, we want to map. For each line, we want to map a function over the line, which is to map over all of the words of the line the function read. So this is correct, and we can test that by writing, giving a type for solve and seeing if the compiler complains to us. Solve is going to be a function from list of int to int. And if the compiler is happy, then that means that all of this weird mapping stuff correctly produces a list of ints. And I think that it will, but let's find out, shall we? Stack GHC of source main. Yeah, compiler says that's just fine. But it is a bit messy to write like map read, right? So what we can actually do is write map like this. We're going to map a single function over each of the lines that we read. And that function is first to call words and then to map read over each of the words. We've added some parentheses and removed one reference to map, but it sort of is like cleaner now, right? And let's confirm. Yeah, still works. Okay, great. Not FG. Not FG. We're not using the shell to handle stuff. We're using it with tmux. Okay. So now all we need to do is write a function that takes a list of int and produces a single int. Pretty easy. Solve rows equals sum of what? For each row, a thing, right? And we can just write max x's plus min x's. Actually, I think it's maximum. Those are two different functions. For x's in rows, right? Is that going to compile? Yeah. And I can pass it input.text, and it produces a plausible output. Except we're not supposed to just add them up, are we? We're supposed to subtract them? What does it say? The difference between the largest and smallest value. Okay. So that is more correct. That is a very small difference. Just 4,000, huh? I guess the smallest numbers are pretty small, and so it doesn't make as big a difference whether you add them or subtract them, huh? Okay. So let's try it. Is this a correct answer? That is the right answer. So great. We did this one much faster, and now you guys don't, at least hopefully believe I'm not a total doofus who takes an hour to write 4 lines of code. Great work. Oh, hang on. This guy was very gruff, wasn't he? I don't know. This doesn't seem in character for him, but great work. Looks like we're on the right track after all. Here's a star for your effort. However, the program seems a little worried. Oh my gosh, I can't read him as worried and gruff. Can programs be worried? Based on what we're seeing, it looks like all the user wanted is some information about the evenly divisible values in the spreadsheet. Unfortunately, none of us are equipped for that kind of calculation. Most of us specialize in bitwise operations. It sounds like the goal is to find the only 2 numbers in each row where one evenly divides the other. That is, where the result of the division operation is a whole number. They would like you to find those numbers on each line, divide them, and add up each line's result. Okay. So, good news, I think. Firstly, let's do the thing we're supposed to do and add commit-m day 2 part 1. We've sort of broken things up in a pretty nice way, I think, which is that we have a list of ints, and we have a solve function, which is just most of what we're supposed to do for part 1 after turning it into a spreadsheet. And we'll have a part 2 that's like doing a different thing on that same list of ints. List of lists of ints. So we'll do the same thing here where we import control.arrow triple amper here. I guess I need one more parenthesis. Yeah. We'll call this part, hang on, I shouldn't be doing this by hand. Solve with part 1, please. Yes, okay, great. Here we'll write part 1, part 2. Yeah, we'll just leave it like that. It doesn't fall. It's an 80 character terminal, and it doesn't fall off the end. How long? The line can't possibly be too long, right? So now we just need to write part 2, right? Part 2. Okay, so great. Now, really, of course, there's going to be a tiny amount of duplication between part 1 and part 2, which is like this sum call. Tell you what, we'll write it this way first, and then I'll show you a different way that I think might be more interesting. A different approach, perhaps. So then we'll write part 2 rows equals sum of what? So here, I think, we will want to write a rather deeply nested list comprehension. There aren't any zeros in our list, are there? Wait, how do I scroll? Okay, I guess using Tmux, I can't use the arrow keys inside of less for some reason? Or the page up and page down? All right, no zeros, fine. That's all I was worried about. So what we can do is say, for what order do you do this stuff in? I actually don't know how to write a proper nested list comprehension in Haskell, which is kind of silly. I just don't know what order stuff goes in. So I'm actually rather than learn that, I'm going to do something different. We're going to write do, which we previously in the Hello World program we saw do used to group IO actions, but it's also an alternate syntax for writing list comprehensions, and it's also a bunch of other totally cool stuff that is not something I'm going to explain right now. But I'm going to just write here something that's basically the same as a list comprehension, except that I know what the syntax is, whereas for list comprehensions, which I rarely use, I don't actually know it. So we'll just write row comes from rows. So for each row in rows, we're going to pull this thing and call it row. And then for each value, say, call it x. And also, we'll iterate over the list a third time. So we're now sort of triple looping over this value and getting a value called y. Now we sort of have two values. Is this right? If we're guaranteed that there's exactly two numbers where this is the case, I think this is fine. I'm going to want control.monad guard, which is basically saying I'm going to write guard that x is not equal to y, which means basically abort this iteration of the loop if this condition does not hold. Furthermore, guard that, actually let's write it correctly just to be sure, y is not equal to 0. Guard further that x mod y is equal to 0. And if that's the case, then return... Why on earth did you go up there? I don't know. Return x div y. So this is taking up many more lines and much more syntax than this first thing, but it's sort of doing something very similar. We're iterating over all the rows, and then within each row, we iterate again to pull out a thing called x, and for each x that we've chosen, we iterate over the entire row again and choose another number called y. We check that they're not the same, and that y is not 0, and that x divided by y, x can be divided evenly by y, in which case we return the result of the division. And I think honestly that should be it, right? Run GHC. Hey, a number. So is this the right number? Like, who knows? But my guess is yes. Let's just double check that I've understood the instructions. Two numbers are, one divides the other. Result, they would like you to find those numbers, divide them, and add up. Okay. Submit. That's the right answer. We did it. Okay. So, cool. Let's git add this. Yeah, and of course we just basically implemented part 2. Yes, git commit dash m day 2 part 2. Cool. On to day 3. We'll try to get another one in this episode. Went by much faster since I didn't stop to explain every little thing about Haskell and every little thing about Advent of Code. Day 3, spiral memory. You come across an experimental new kind of memory stored on an infinite 2-dimensional grid. Each square on the grid is allocated in a spiral pattern, starting at a location marked 1 and then counting up while spiraling outward. So they've got this picture here. So we're sort of going like this. Okay. While this is very space efficient, no squares are skipped, requested data must be carried back to square 1, the location of the only access port for the memory system, by programs that can only move up, down, left, or right. They always take the shortest path, the Manhattan distance between the location of the data and square 1. So this data in square 1 is carried 0 steps. From square 12, we have to walk 1, 2, 3 steps. Okay, so our puzzle input is a large number, and we have to figure out how to walk that large number back. We have to figure out where it would live on this spiral. And that's actually, like, doesn't sound obviously easy. I overheard... I've been subscribed to the Advent of Code subreddit, and I overheard, like, some discussion of this one. And I was like, but I'm trying to do this, like, without spoilers and so on. And so for that reason, and because there was just a ton of noise of, like, 1 million people posting their solutions, I have at least temporarily unsubscribed from Advent of Code. Maybe I'll resub once I'm done catching up. I don't know. We'll see. Okay, so is there, like, some... Obviously, there must be some pattern for, like, how far away a thing is. And, like, in principle, you should write this down, I guess, on, like, pen and paper and compute a formula and, like, write it. But also, the number 28,000, 26,000, 265,000, like, it's just not that large. Like, you could write a program which, generates an arbitrarily large grid, and yeah, generates, like, basically a lazy list of coordinates on this grid system. And this is obviously not the most efficient way to do it. Like, you should be able to work this out on pen and paper, but I don't really know how, because, like, okay, so in the first... Here's an interesting thought. The first area, the very center sort of base case, is an area of size 1 squared, i.e. 1. And this area is of size... I can't select a square, but you guys know what I mean. This area here, the inner ring, is an area of 3 squared minus 1 squared. That's how many numbers were used up. 9 minus 1 is 8. The third ring is of size 5 squared minus 3 squared. Or alternatively, you could just say all of the numbers up to 5 squared are within this first grid. And we could therefore work out at what layer of the grid... on which ring we find our puzzle input by just, like, saying, you know, square numbers until you get one bigger than that, and then divide by 2 sort of thing, right? Like, something like that. subtract 1, divide by 2. I don't know exactly. Or square odd numbers until you get one larger than that. That would tell us what ring it's on. And each ring always starts from the bottom left corner of the ring. Bottom right, I should say. No, it doesn't. Bottom right plus 1 north of that, I guess. And so in that way, I think we could do this, like, not exactly with pen and paper, because I don't want to square 3-digit numbers, but close, right? It would be on, like, about the 100th part of the grid, and we could compute what is... Anyway, so we could do that. But I think that it's more fun to write, like, a program that just generates the positions of these things, right? So how would we do that? This is a more difficult puzzle than I expected on day 3. I think maybe it's easier than I thought, and I'm just not very good at solving puzzles. And it's not like super hard or anything, but it's going to take a little bit of thinking and a bit of doing. So what does a program that does this look like? It's sort of carrying a bit of state around, where that state is the number that it's currently going to generate, a cursor sort of where in the grid it is, and also some way to know at what point it needs to turn, right? What are the... So, one approach would be to say, like, you can sort of imagine as a person, you walk this way, and then this area in front of you is blank, and so is this area. Like, should you turn left or go straight or what? I think you should say you should always prefer to turn left if that will not take you to a space you have already visited, right? But it's a little difficult to keep track of what spaces you've already visited, I think. You could actually store like a 2-dimensional array of things. I think it would be better to store like a map from position to number and just gradually be updating that. I say updating. Of course, Haskell does not let you modify things, but there are facilities in place to let you do stuff sort of that feels the same. That's one of the cool things about Haskell, is that you can opt in. It has, like, I wouldn't say syntactic sugar. It has powerful computational constructs that are under the hood implemented in the same way using just recursion without modifying things, but which feel like, that allow you to behave as though you were modifying things in strictly limited parts of your program where you think that helps with readability. So we could sort of maintain a map from position to item and gradually fill it in while walking a little square. This does not seem very elegant, however. Is there some simpler way? The thing is, I'm sort of tempted to just do this on pencil and paper, actually. But what bothers me is that I don't know what part 2 will be. Will all of the pencil and paper work be wasted and I'll need to draw out the spiral by hand? Or draw it out, like, explicitly in a program and do something interesting with the values? I don't know. I mean, the number that we're squaring will be like a little bit more than 100, probably. Like between 1 and 200. And closer to 100. Like, for example, let's suppose that we wrote 105 squared. Oh. It's 5 zeros. So no, that's not close at all. But we could write, say, head of take while... no, drop while less than or equal to... Let's actually write less than this of head of that, a drop while of this, iterate map square of this. Well, that's not helpful at all. Excuse me. I forgot to mute. I'm still a little sick, which is why one of the reasons I'm late recording. Couldn't start on December 1st. I was sick and on vacation. I'll try to remember to mute in future. So this tells me where the first... What is the first number that is on the same ring as the thing we are computing? Alright, so we can actually just square root this. 515. Okay. So, fine. So we could say, let n equal this. n minus 515 squared. Oh, let n equal this point 0. Okay, looks like I computed that wrong. It should actually be 513. But okay. So it'll be the 1980th item on this ring. But that still doesn't really help me figure out where on the ring it is. Something like that. I don't know. This is all very, like, fuzzy and not right. But this is, like, sort of how you might do it on pencil and paper. Oh my gosh, I need to turn this music off. It's distracting me. Cool music, but, okay. So, how are we for time? It's been half an hour. I feel like I really should draw out the grid. And I think that this idea of keeping the grid as a map from position to index is a good idea. It's no problem to keep a few 100,000 things in a map, no big deal, of course. Yeah, and then I guess I need to, like, you have to import a library to get a decent map in Haskell, I think. I need to look up, like, how to do that, and I should look up how to get Intero mode going so that I can have a better Emacs thingy. So I think that I'm going to declare a break here. We did day 2, part 1 and 2, but we haven't actually done any of part 3 yet, except we've done a lot of thinking about it, I guess. So we're not really meeting up with my goal of doing multiple parts in one episode, but maybe we'll get there someday. Anyway, so gonna go do that. See you guys in the next episode. Thanks for watching.